Azure Cognitive Search facilitates knowledge mining by integrating various AI skills. Skills are modular components that extract specific insights from unstructured data. Azure offers built-in cognitive skills for text analytics, language detection, and more. Occasionally, predefined skills may not address specific business requirements, necessitating the development of custom skills. These custom skills extend capabilities by allowing customized, domain-specific information processing directly integrated into Azure Cognitive Search skill sets, enhancing the solution's efficiency and accuracy. Azure Cognitive Search offers the following types of skills: built-in skills, readily available and easily integrated, handling common tasks such as OCR, language detection, and key phrase extraction. Custom skills, user-developed to address specific needs not met by out-of-the-box functions, using code frameworks and languages of choice, providing extensibility and flexibility. Selecting between built-in or custom skills depends on factors like complexity of requirements, specificity and uniqueness of the domain scenario, desired level of accuracy, and customization. The architecture of a custom skill typically comprises back-end logic, usually an Azure function or API developed in languages such as Python, JavaScript, or C#. HTTP endpoint, publicly accessible URL, secured and managed in Azure, processing requests from Azure Cognitive Search. Integration and skill set, defined within the Azure skillset JSON schema, referencing the created endpoint. This design pattern ensures effective communication, scalability, and integration within the Azure Cognitive Search environment, allowing extensive customization tailored to your business needs. When creating custom skills, developers commonly utilize Azure Functions, preferred serverless environment offering agility, scalability, and easy management. Azure App Service, suitable for complex APIs needing stable, continuously running hosts. Languages supported: Python, JavaScript, Node.js, C#, .NET Core, Common Machine Learning Frameworks, TensorFlow, PyTorch, Azure Machine Learning SDK. Azure tools like Visual Studio and Visual Studio Code streamline the development, integration, and deployment processes. To create a custom skill API, set up project environment. Choose an Azure-supported language. Prepare a project using Azure's tools, e.g., Visual Studio Code. Implement logic. Develop specialized, domain-specific functions in the chosen language. Deploy endpoint. Utilize Azure resources such as Azure Functions or Azure Web Apps to host your API. Example code snippet: Python Azure function Python import logging def main req func.http request -func.http response. Data equals req get result equals customer logic data return func.http response json.dumps result. Securing your API endpoints is essential to prevent unauthorized access and data breaches. Azure provides robust mechanisms for endpoint protection. API keys, simple keys attached in request headers to authenticate Azure search requests. Azure Managed Identities, automatically manage service credentials, minimizing manual handling of sensitive data. OAuth and tokens, for extensive authentication requirements where secure token-based mechanisms are essential. Integrating such security measures ensures the cognitive search solutions deployed firmly adhere to compliance standards, safeguarding sensitive information. Deploying a custom skill involves several Azure services. Azure Functions or App Service for executing code with built-in scalability and reliability. Azure API Management, optional for managing, authenticating, and monitoring endpoints. Typical steps: write and test custom skill API locally. Use Azure CLI, Azure Portal, or DevOps tools to deploy REST API. Validate deployment success by testing endpoints directly via HTTP request. Once the custom API is ready, integration involves updating the Azure skill set within your cognitive search indexer configuration, adding JSON definitions pointing directly to your deployed API endpoint. Example skill definition in JSON. JSON skills, @OData type, #Microsoft, skills, Custom.web API skill. URI, https://your-endpoint, HTTP method, post, inputs, name, text, source, /document/content, outputs, name, result, target name, custom result. Custom skills require defining explicit mappings of inputs and outputs. Inputs, extracted fields from documents to feed precisely to skill processing. Outputs, resulting in enriched values consumed subsequently in the pipeline or search index. Ensuring effective critical feature mapping guarantees proper flow of data, contributing to enhanced accuracy and relevance. Careful attention to input-output schema consistency is essential to avoid processing errors and ensure seamless integration with other skills and the end-user search experience. The Azure ecosystem offers comprehensive tools for monitoring custom skills and diagnosing potential issues. Azure Application Insights, detailed analytics providing insights, logs, and diagnostics. Azure Portal Tooling, built-in metrics, logs, and alert systems. Implementing proactive monitoring practices contributes to quickly pinpoint performance bottlenecks or logical errors, enabling prompt rectification. Establishing effective monitoring routines supports maintaining optimal operation and user satisfaction. Key considerations for custom skill performance. Latency. Custom skills add latency to indexing. Optimizing function response time is crucial. Scalability. Consider serverless hosting options, e.g., Azure Functions, for dynamic scaling. Resource optimization. Efficient algorithms and memory management improve throughput. Regular evaluation and optimization during lifecycle stages help maintain service responsiveness and enhance user experience. Developing effective custom skills involves designing for idempotency and fault tolerance, ensuring secure endpoints through authentication methods, utilizing asynchronous and lightweight implementations for high scalability, clearly documenting API contracts, input-output schema, implementing comprehensive monitoring and logging strategies for troubleshooting. Consistently following established best practices ensures robust, secure, and highly effective custom skill deployments within Azure Cognitive Search skill sets.